4. Let me let whoever came in. Okay. So I should have a point at +2 and then up 1, 2, 3, 4. So I should have a point right here. And I should have a point at -2, 0. So down here, and a point at 6, 0, which is over here. And I'm gonna draw, oh man, I'm gonna draw in green, but I should be drawing with a dashed line because my function has a strictly less than sign. So I'm gonna use a dashed line to indicate my function coming down, and I have my second absolute value function. And then I'm going to shade in with green everything below that function. Okay. All right, now my solutions are going to be inside of this little diamond shape right here. Okay, so they're along here, but not on this line because on that line is dashed. And then inside of here. So these are my solutions. Okay. Little diamond thing right here. What questions do you guys have about those solutions? Any questions? Questions on how to, oh, go ahead.
So that'll be, so how will you figure solution? You said it was inside like the between where they cross, right?
Yeah, so everything in here.
So, wait, what do you mean by that? That will be your solution?
Literally any point inside of here is a solution.
Mm-hmm. Oh, okay.
Okay, so there are going to be infinitely many solutions here.
Mm-hmm. So you can write any you want?
Yeah.
That, okay.
But it has to be inside of there. So if we look at Desmos, let's see. Let me zoom in a little bit so that we have more tick marks. So for an example of a solution would be 2, 2. Okay, so an example would maybe be 2, 2, because it's inside of this box. It's right, okay, it's in between the two shaded regions.
Okay.
Okay. Our points, this is open for anybody. Is this point right here and this point right there, are those solutions?
Yeah.
Why?
Well, because they're inside.
Well, they're not inside. They're like right on the edge.
I mean, wouldn't that, because they're so like, it's a point where they both combine together. You said anywhere where they're like combined together.
Right, yeah. But what about this, the red function, red absolute value function? What's going on with its border? Is it solid or dashed?
It's solid.
On the red?
Oh, it's dashed.
Yeah, and what happened with dashed? What did we talk about with points on the function?
They're not included.
Right, so is -1/2, 3/2 a point that is in both pieces of the function, both functions?
No.
No, so we cannot include those. Okay. Thank you for talking through that with me.
Yeah.
Okay, any other questions before we move on to a new example? Okay, if there are no other questions, I'm gonna blow up this so you guys can see it a little bit better while we're not using Desmos for just a second. All right, so we're gonna do another set of functions, another system of equations. Ooh, all right, not equations, inequalities, because we have inequality symbols, not equations. Okay, so in our second example, I want you guys to graph y is greater than or equal to the absolute value of x minus 3 minus 2. And also y is strictly greater than x plus 9 minus 5. The absolute value of x plus 9, excuse me, minus 5. Okay, so those are the two functions I want you to graph. So open up a tab with Desmos and go ahead and graph those, and I will graph them with you. Okay, so that's the first one. Y strictly greater than. Okay, I'm gonna zoom out my graph so you guys can see, oops, how my graph turned out. Okay, so you should have something like this. I'm gonna use purple and green too, so I'll do the same. So for mine, this one's gonna be green. This one was green up here. And then the bottom one's purple. Okay, those dots are just to indicate the color that I'm using, not anything else. Okay, so once you have those graphs, I'm gonna go ahead and sketch them out on my paper. Is there a question?
Give me.
Henry, do you have a question?
Oh, no, I'm sorry. I didn't mean to unmute myself. Sorry to my little sister.
Okay, so we're going to have a point at 1, 2, 3, negative 1, 2. So we're going to have a point there. Oops. And that should be a green point. We're going to have a green point right there. Then we're going to have a point at, it's at negative 9, negative 5. Ooh, so this one's going to be far. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And down here. So my purple vertex is going to be over here. These are both facing up, okay? So I should have a function that goes like this. I'm just guessing my points this time. So my green should have solid lines, okay, because it was greater than or equal to. My purple should have strictly greater than, so it should have dashed lines. So dashed, dashed. That was a really bad drawing. Sorry. And then let's just see where this point of intersection is. Oh, it should have even been over here. So I did a really bad graph. But we would shade all the way up here. Shade all the way up there. Okay, and hopefully your graphs were more accurate than mine. Because this point of intersection should have been, it was like at negative 1.5. 2.5. So that intersection should have been way over there. So I apologize for my bad drawing, but there it is, something like that. So I have my two functions overlapping, okay? And maybe in this problem, they ask you to name 4 solutions, okay? This is not a solution, okay? Because we have that dashed purple line there, okay? Those points are not included. So when we're naming our 4 solutions, we want to look in this region up here that's shaded, okay? So I'm going to zoom in a little bit, and we can just pick some points out. So like 0, 10 is in that region. I'm going to say 0, 10. And I want to hear what some of you guys have to say. Jaikeem, are you here? Jaikeem here?
I'm here.
All right, can you pick another solution for me? There are infinitely many, so you have plenty of options. What's something in the purple and green shaded region in here?
Say 10-5. I mean, not 10-5, but 5-10.
So 5-10. Yep, that's the solution. Thank you very much. Perfect. All right, let's hear from somebody else. Jarrell. I don't think Jarrell was here. Jordan wasn't here. Jason, can you message me a solution? Madison wasn't here. Man. Regina, are you here? Regina? Okay, Henry, will you give me a solution? Henry?
Yeah.
Can you give me a solution? Something in the green and purple region here.
-5 and 10.
-5, 10. Yep, that's a solution. Thank you very much. Daisy? I need one more solution.
3-10.
So let's see, 1, 2, 3, 10. Yep, perfect. Very good. Okay, so there are infinitely many solutions you can pick. They don't have to have integer values as a solution, but there are going to be infinitely many integer value solutions anyway. So that's great. Good job, guys. All right. The next example, I'm going to show you an example that, I mean, it's not really that much different than this one. It just looks a little different. Okay, so I'm going to flip this page. Is everybody okay with me flipping the page? Actually, I'm going to open this up to a question because the next example is pretty similar to this one. Regina, you said your computer froze, but your answer was -5, +5. Unfortunately, -5, +5 is right here. It's not inside of the green section. It is inside of the purple section. But thank you for responding. I really, really appreciate that. You could do maybe -5, 15 or something like that. That's definitely in there. That would work as well. Okay, so I'll add that. Regina's solution, -5, 15. Okay. All right, so now I have a question for you guys that I want you to answer. So can you find a system with no solutions? Okay, so I want you guys to think for a minute and try to come up with a system of equations where there's no overlapping at all. You can sketch it out on your paper. If you don't know how to come up with the equation, that's okay. I want you guys to take just a minute. So at 1:09, I'll check back in with you guys. And I want you guys to come up with a system with no solutions. You can also play around on Desmos and try to change your equations so that inequalities. Try to change your inequalities so that they have no solutions. You can do that as well. Okay, so why don't you take a minute and we'll take to 1:09 and then we will talk about that together. Okay, and we'll do that on the back.